The coolest day of the year. It's a wonderful day of the year. I hear music. I hear great music. I'm here. Jennifer Axley is here with us today. We are here to celebrate the coolest day of the year. I'm Ernie Roberts, and this is Jennifer. Why are you looking at me so funny?
What is this?
Cool. I came with shades. It's the coolest day of the year.
Ernie, that is not what we meant for this show today.
What are we on?
This is our Christmas show.
Oh, it's Christmas Day. It's Christmas Day. That's right. The most
there. That looks more appropriate.
Got it. Yeah. All right.
Well, hey, guys.
I could be an elf today. Oh, my gosh.
Ernie the elf.
Ernie the elf. What we can do. All right. And we decked the Elmo with
Elmo
the stocking.
has been decked. The stockings have been hung.
Oh, we're going to have a great day today.
And
yes, it is. You said Christmas, right?
Christmas
Day. Folks, I hope you've had a great Christmas Day. Jennifer, what are we going to do when it's Christmas Day here?
Well, you know what? Christmas is a time to be festive. And a lot of people don't realize it, but we can be festive with our decorations using our math. And so we are actually going to use some solid shapes today. We'll probably just get one done because we don't have a lot of time on our show today. And we're going to choose to use a real simple one, something that is known as a rectangular prism.
What's a rectangular prism?
What
Do we have a slate on that?
is a rectangular prism?
See, they got a slate about that. It says Merry Christmas. They should have done that earlier, then I would have known what day it was.
You would have, and you would have dressed appropriately, but at least you have on your red. What is a rectangular prism? A rectangular prism is a solid figure, and it actually has 6 sides. And Ernie, I think...
we got one.
Oh, you do right there, and you've got a larger one right over here on this side.
Hey. It looks like a Christmas package.
Look at that.
We could wrap it. We could fill it. It had candy in it.
We could. I did not bring this. This is not your present. But this is a rectangular prism, and this is what makes a rectangular prism. First of all, it is a prism if we have P-R-I-S-M, if we have 2 bases. So basically, if there is a top and a bottom to it, it's a prism.
And then we have the lateral sides, don't we?
And on a on any prism, all of your sides, if they're folded out, are rectangles. But this is a rectangular prism because my bases are rectangles.
It's empty.
I know,
Ernie. It had candy in it.
I know, Ernie. Just put that aside. I told you. You have spoiled your dinner.
All right. Yep.
So we have a prism.
I want to do that because 6 o'clock dinner coming up tonight. 6:30 dinner after the show.
Okay. So your prism has 6 sides. Your bases, there are 2 of them. They are, the reason this is a rectangular prism is because they are rectangles. Now, that is a nice festive little prism there. But
it says ho, ho, ho on it.
We are going to, Ernie, I have a project for you today.
A project for me?
Yes, we are actually...
Jennifer, you never bring me anything. You brought me
a
project.
I brought you something to do today.
It's Christmas and you bring me a project. Okay.
I brought you something to do.
Right. What have we got?
We are going to make a rectangular prism, and what we have here...
You've got sitting down on that Elmo. Let's see what we got.
Yeah.
Elmo's decked out. Elmo's got something to be. There we go.
There we go. So what you may or may not be able to see on the camera is this is a folded out version of a prism. It's like I have taken a box and I have totally unglued it, like maybe a box that you would get for a Christmas present.
We call those nets, don't we?
We do call those nets, N-E-T-S, and any time that we take a solid figure and we make it a flat figure and represent it that way, we call that a net. So what I have for you is a net of a rectangular prism.
And I get to build the rectangular
You
prism?
get to build it. And what we've done is we've got some nice little dotted lines for you. And these little guys right here that are not rectangles, these are tabs. Okay. And what we're going to have you do is fold those in. Like maybe you can hold that up where they can see it a little bit better.
So we're going to fold it in. Up the gloss. There I am.
There you are. So we're going to fold those tabs in, and you can make a box with that. So I'm going to have you work on that a little bit.
You trust me?
And I'm going to trust you over there, and I'm going to set you to work.
All right. I trust me too, I hope. All right.
Yes. Now, while you're working, would you hand me that other prism that we see that has some cubes
multi-dimensional.
here?
There you go.
Yeah.
Put that on front
now,
of the
here
camera.
is another rectangular prism. I'm putting it under Elmo so that we can see him.
There you go.
And what you can see, he's a solid figure. He has length, he has width, he has depth, and he is built of cubes. And I'm almost afraid to start taking these cubes out because when I was putting these cubes together.
So it's not a Rubik's Cube, is it?
This is not a Rubik's Cube. We are not going to start twisting this to try to get all the colors on the same faces, the same sides. But when I was putting him together, I actually had these little cubes that are a centimeter long, a centimeter wide, and a centimeter high. And I can actually take my little ruler and I can lay it against these cubes, and what we can see is that each one of those has a length of 1/2, has a width of 1/2, and I don't know if we can really see, he has, if I uncovered my fingers, we might, has a depth of 1 centimeter.
Okay.
I said 1/2. I don't know what I was thinking.
I was thinking,
Ernie.
well, I thought you were getting in a new culture here.
Yeah,
you told me there were no fractions in this show.
No fractions in this show. Actually, the nice
That's
thing.
our Christmas present to everybody,
Yes,
I guess.
and the nice thing, because we're working with centimeters, everything is always based on 10, so that's going to make it really easy to figure. Now, the first thing is, I would like to know, Ernie, how many cubes there are in here. Would you like to count those for me?
I could probably count. You know, they allow me to do this once in a while on the show.
Yeah.
But you know what? Rather than count them all individually, I'm noticing that I have 1, 2, 3, 4. Let's see if we got that in there. Yeah, let's check that out. All right, very good. Let me go down the other side here. 1, 2, 3, 4 this way. And I count 1, 2, 3, 4, 5, 6 that way. So that tells me, whoa, that's one row of 24, right?
That is one row of 24 cubes. If I counted 1, 2, 3, 4, I could skip count, but 6 4s are 24 because that's an area.
It's kind of like a stack, isn't it?
Yes.
An area. So I can stack 5 of these because I see 5 going up here. 1, 2. We're coming up. You can't see that 3-dimensional. Let's see if we can. Nope. Elmo's
It's
not.
kind of hard. So we can maybe turn him this way.
There we
We're
go.
in a little danger
There we
here
go.
of losing our cubes.
1, 2, 3, 4, 5. So there are 5 stacks of 24. Am I right?
Right, and that would actually multiply out to, I do believe that comes out to about 120.
Okay, can we go to a slate here? I think
Yeah,
we've got,
well, and when I want to talk about how many cubes of any dimension are in a figure, I'm talking about volume.
There it is.
And while I could take these apart and count every single one, and then Ernie was pretty smart elf over here because he recognized that I could get the length of one of these flat. No, that's how he got this job.
We
could do one of these sides that had 24, and then he knew there were 5 of those 24s. And the thing about a prism, a rectangular prism, is if I take the base times the height times the length, or the length times the width times the height. We call those dimensions different things, but length times width times height's pretty standard. I get what is called a volume. So we always talk about volume being in cubic units, and the reason why is that that's how many cubes of a given size can fit in a figure. And since my cubes are a centimeter long, a centimeter wide, and a centimeter high, these are cubic centimeters, and there are 120 of these cubic centimeters in this prism.
You want to write that down on the Elmo here, those numbers?
I could, because how did I
forget
find
those
that?
countings, yeah.
How did I find that again? I know that volume. Oh, my pen. I may have to get another pen.
Well, we get use one of the fatter ones over there. You've got a blue and a maroon.
Okay, I've started on these words.
You're good. I can read it.
So my volume of a rectangular prism can always be found by taking my length times my width times my height. You are doing a great job over here, by the way.
Don't get too confident yet, girl. We'll get there.
Oh, my goodness. I'm looking at Ernie the Elf's hard work over here and making his decoration. And
because the little hole punches are disappearing. I don't know where
So the volume of any rectangular prism is length times width times height. And the dimensions on my particular prism were 6 centimeters times 5 centimeters.
I keep punching these things, but they're
4
disappearing. They're
centimeters.
getting caught
They're
inside
in
your
the little
hole
catcher.
puncher. Okay.
Oh, goodness. I'm going to have to teach Ernie how to use some basic office implements over here. So when I multiply that
They're
is
hiding them from me.
120
I know
centimeters
you're tight.
cubed. And I have to be careful because whenever I start talking and laughing, I do something really silly. But I believe I've computed my volume correctly here. So that's the nice way to not have to count the number of cubes. And this is why we say that volume is always measured in cubic units. So that would be the volume.
You know, that's sort of like thinking inside the box on that one, isn't it? Ah! Cha-ching!
Ernie, you are so funny.
Christmas Day, you're going to
You
go down
are
in history
so
here.
funny.
You're
I
going to go down in
know.
history.
Yeah. Okay.
You
Now,
didn't see that one coming
I
either,
have
did you?
another net that I want to show you guys, and I hope this shows up okay underneath the Elmo. This is a net, and you can't see all the sides, but I'll move him around. This is where I took the net that I was giving Ernie, except it doesn't have the tabs on it because I'm not going to actually construct this one. But this one actually has centimeter grids written out on it. And then again, that's where I can take my little centimeter ruler and I can see that each one of these little squares has a length of 1 centimeter and a height of 1 centimeter. So each one of these is a square centimeter. And what I want to know is roughly how much paper did I give Ernie over there? I gave him
some red paper.
Some nice pretty red cardstock. And by the way, if you were to make one of these at home, cardstock, heavy paper, cutting out of a box, get busy, you're not finished.
Oh.
Cutting out of a box, that works really well if you were to actually want to make your own ornaments. But what I would like to know is, and we're not going to go to the math yet, we're going to do some counting, is I would like to know actually how many of these square centimeters are in Ernie's net, not counting the tabs. So I didn't make tabs on here.
Yeah, I think we got a slate on that. Can we see that slate, guys?
Not yet.
Not yet. Okay, never mind.
Not yet.
She's running the show today. I'm sorry.
So I actually kind of want to see how much I am covering. So first of all, I'm just going to do a little counting of each of these sides of this figure. And so if I started counting out by hand, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. But when we start multiplying in 3rd grade and we look at rectangular figures, we learn that we can take the number of square units inside and find those by multiplying the length times the width. So I have a length of 6 times a width of 4, and the area of this one side is 24
That's what I said earlier, wasn't it?
centimeters squared. It sure was. That was when you
that was
counted
that
the
area.
top. When
I
you
know that.
counted that top surface of my cubes a while ago, that was 24 centimeters squared.
I hope you don't need the cap on the glue stick. I think I lost it.
We'll get it later. Oh my goodness, I can't do anything.
You know,
with this
good
now.
help is hard to find. You know
Good
that.
help is hard to find. Good elves are hard to find.
Yeah.
If I wanted to take a width of the area of one of my smaller sides, I have 4 centimeters
out of that
going
pretty
in
quick,
one
didn't you?
direction, 5 centimeters going in the other direction, and that is going to be 20 centimeters squared. If I go over here to my other side, I've got 4 times 5 again, and that's another 20 centimeters squared. My nice big face over here is 6 times 5, which is 30 centimeters squared. I've got another side, 6 times 4, which is 24 centimeters squared. And then I have my last side that would be wrapped up, which is 6 times 5, which is 30 centimeters squared again. So what I know is that the area of each of those sides of my net, I have figured those out. And if I add all of those up, I have what is known as the surface area of the solid. So let me actually find this surface area and then we'll show our slide on the surface area. So if I were to add all of my 6 areas together,
Here we go.
I have 24 centimeters squared. I have 20 centimeters squared. I have 30 centimeters squared.
You got a lot of centimeters
I
squared
have
over there,
20
girl.
centimeters squared. You
You
know,
really
I'm going to
do.
do a little bit of good math here in a second too. I have 24 centimeters squared and I have another 30 centimeters squared. And again, where this came from was where I took each of those sides and I figured the area of each side of my net separately. Now, I could add all of these up, but you know what, Ernie? I like to save myself some work. So I can actually regroup these numbers. And look what I can do, because I'm saving myself some work.
Okay. What are you going to do?
I have 2 of these sides that are 24 centimeters squared, and I can actually then say that would be 2 times 24.
Well, that's kind of like doubling, isn't it?
That is doubling. That's what we do when we multiply something by 2. I also have 2 sides that are 20 centimeters squared, so I can say 2 times 20 centimeters squared. And I have 1 more pair of sides that are alike, and those are 30 centimeters squared. And by the way, the nice thing about a rectangular solid is that my sides that are opposite each other are going to be congruent, which means they're going to be the same. Now then, I can actually do my math.
That mean the areas are the same, doesn't it?
That would be. So that's where I got to double. So 2 times 24, that is 48 centimeters squared.
Double.
Plus 2 times 20 is 40 centimeters squared. Plus 2 times 30, my work's a little sloppy over here, but that is 60 centimeters squared. And when I add all these together, I know that 60 and 40 is 100, so I'm going to go ahead and know that that's 100. So 48 centimeters
That's like
squared.
$1, isn't it?
That is like $1. Plus 100 centimeters squared, and that is going to give me, whoa, what have I done again? I have done some silly, silly math, or maybe not. Perhaps I did my math right this time and didn't do my math right the first time that I did it. I believe that's my case. Yes, so 148 centimeters squared.
What'd you get the first time?
I had 168 centimeters squared.
That's why
but when I'm looking at my
work.
I know, and I didn't check my work when I was doing my math, but this is the correct sum, and you guys can be even checking me if you're watching this evening. Now, what have I just found again? I have found the surface area of my solid, which means if I were to take this little net that had all of the sides, and if I were to fold him up and make a box.
Oh, little net, how lovely are your... Anyway, I don't know.
And if I were to make a box, that would be the amount that it would take to cover. It is Christmas, and we are holly and jolly. So let's see a slide about surface area.
Oh, yeah, we got a slide.
So how can we find the surface area of a rectangular prism? And basically what that is the sum of the 6 rectangles that make up the sides.
You know, I think when you add those up, you're going to get 148 off that one.
Thank you.
I just thought you'd like to know that.
That I was right this time?
I think you're right. But 168 was a fun number, too.
Yeah, I'm not really sure what happened then. I was actually doing my real job while I was doing this.
I got to tell you something, though. As you know, you're here with me as a co-host today. This is much better than the co-host I had on Halloween, because he would just sit there and grin and had a light coming out of his nose.
He was a real straight man,
He was named Jack, Jack-o'-lantern. But anyway, you're so much more fun. We appreciate it. So
let's recap some of the math we've done, and I think we're almost ready to see what Ernie's project is, but let's talk a little math first. So we have found the volume, which is what fits inside of a solid figure. That's the number of cubic units. And for a rectangular prism, that's the length times the width times the height. We also found the surface area, which is the amount that covers it, which is the sum of all the 6 sides on the net. And those are things, we start learning what these solid figures are in elementary school. So I know that watching us today, we have some 3rd graders and some 4th graders, and maybe even some 2nd who already know what these are called.
We've got some adults that are enjoying this today, too.
But those guys in 2nd, 3rd, and 4th grade, they already know the names of these figures.
Awesome.
And then in 5th grade, they actually learn how to find that volume. And then in 6th grade, we take those nets and we actually spread those out, and we learn how to find the surface area that way. So we've got a lot of good elementary math, and you taught high school geometry.
And in high school, we use the nets also. We formulate our basic figures, and then we get to, we come into the rules. We come into basic rules about the volume.
And there are all kinds of figures that you can do, and you teach surface areas and volumes of a lot more complicated figures even than just these 6 sides.
And it all boils down to square units for area cubic units for volume. A lot of times we forget and don't think those are very important, but they really are because as you see the blocks
because of what they
here,
mean. Because again, the volume is what fits inside. It's the number of cubes that comprise it, and it's 3 dimensions. And the surface area is the number of square units, like if we were painting it or covering it with some paper, what it would take.
Ooh, wrapping presents. That was a good thing. You know, right there, that's what boxes are. They're rectangular prisms.
They are rectangular prisms. And you know, if you ever have a box, you know how they glue up the sides? If you don't need that box, now I always save my boxes at Christmas because I need them, but if you don't need that box, you could actually unglue those sides and fold it out and you would have a net.
That's kind of what happens. It really is what happens, you know, so many times we crush boxes before we recycle, before you put them in there. So it's the same thing, unwinding. I'm itching to let people see my box.
Okay, Ernie is very proud of himself because I'll tell you the truth, I told Ernie that I wanted to make these decorations today, and he was a little skeptical. And when I told Ernie that I wanted him to help me make these decorations, he wasn't so sure about that either.
I've got to tell you, this takes me back to high school days. Way back. We aren't going to say how far back. But where we were told to build some volumes and such. And we weren't given the, quote, nets to work with. I don't know if we knew what nets were back in those days.
Maybe we didn't use those terms.
But I just cut out, I did a cube. It was the easiest thing I could do. I just cut out 6 squares that were all the same and glued them together, and I got an extra credit point.
Oh, by the way, I see another rectangular solid over there. Do you see that box that says tape?
Yeah, throw that. It's colorful. It's got some of those Christmas colors, green and.
It's got some nice Christmas colors in. I borrowed this from my desk. It's a little shiny, but it's some tape. And if you will look, it folds into a rectangular solid. And if I were to actually unfold him,
oh, you're gonna have a net? Do you think you can go all the way with that? Pull it out, pour it apart, tear it apart, tear it apart. All right. There she is.
And again,
Jennifer actually has, we have part of it
now. Well, and what you've got,
well,
you've got some extra pieces here. This is like where Ernie had tabs.
So you can hold them
This is
together.
the same little deal so that it goes together. So we had some extra. So we've got solids. Now, if you all decide, if you guys at your home would like to do something like this, if you're full from your holiday meal and you're sitting around, you could just go get online and you could do an internet search for nets of solid figures, and you will find prisms, you'll find some pyramids, and maybe it'll be a nice little thing to do after you've watched Mathline this evening.
Snowflakes and stars that we've had rolling around through here, all sorts of colorful
do all
things.
kinds of, okay, Ernie.
You gave me some things to decorate with, and then we're going to show, she did a really nice one, by the way, really truthfully here. But this is, well, there went one of the little bibs. They're little giblets and it's actually little parallelograms. Can we get it? There, we got it. And so there's the top. It opens up. There's nothing inside, but candy will be good. And then we just work it around. It's come together. Oops.
And you saw what it looked like at the beginning of the show. You saw the red figure that was unfolded.
It's pulled together.
That's what you have made.
And you know, and folks, really seriously, many times you've heard the words origami. That's a lot of what this is nets and working together, things together, and a pattern, developing some sort of design, some sort of figure. And they make grand ornaments for your Christmas tree, and your kids feel pretty proud of making and creating those also. Let's bring yours up here real quick, Jennifer.
Yeah, I was practicing my net the other day, and again, we made these out of cardstock because it's a little bit thicker.
From that.
Let's hold on. First of all,
we got to get it upside
Christmas.
down. Yeah.
And look how I decorated my side. Do you see? But look what I did. I have
She look like little snowflakes there.
Well, but I also have 3 triangles, and I put them on top of each other to make a tree.
You
so
are
I used geometry to do my geometry, and then I've got some snowflakes. I decided that I wanted to hang my ornament, so I punched some holes just in the top of the lid, punched a hole, and I just have a rubber band. And then, look here, I gave a message because I said,
Mathline to you, and it says a Merry Christmas.
Mathline to you.
You know, maybe it's time. Let's take a look at that last slate we've got coming up here. What we got going up there, guys? We have a Merry Christmas from Mathline also to each and every one. You know, Jennifer, we've got just a short time here, but it's Christmas. It is, we always consider one of the most wonderful times of the year. But you know what? We came to you today from 6 to 6:30. We're going to be back tomorrow, and we're going to be back next week with theme shows. But we'll be back at the beginning of next year, January the 5th, live. So let's say one more time to them all out there, what are we going to say?
Merry Christmas
from
Mathline.